Is my screen visible?
Yes, ma'am, it's visible.
So, since yesterday I feel that I covered a lot of things, so for today I'm keeping it light and I'll not be covering the X-array and Rio X-array. We'll just take another example using Rasterio only. And there we'll try to do the batch processing. Like yesterday, we have seen that how can we use Rasterio to do any kind of analysis you in a single band. If you have, then let's suppose if you have a folder, inside that folder you have multiple bands, or by bands I mean multiple TIFF files if you have, and then you want to do any kind of a batch processing in all those files and create a output folder where you want to extract those, write those new analyzed folder files in it, and then if you are doing some kind of analysis in between, you want to save that output as well. So we'll just do that example, that second problem statement which was there in your slides for the rasterio. So, multi-band raster is basically nothing. Let's suppose multi-band raster is such. Let's suppose you have a one single TIFF file, and in that one single TIFF file, you have multiple bands already stacked within that. So, but Landsat gives you different files for different bands. So, if you download any data from Landsat, something like this you get. Just a minute. So these are only seven bands that I have kind of downloaded from the Landsat. There are total 13 to 14 bands if I also take other like aerosol and other TIFF files from that. But these are the seven main bands which are required for all kind of analysis, any indices if you want to calculate. So let's suppose these are the few of the bands. So it provides you different TIFF files. So that's fine. It is a single band file. But in few cases, there may be a possibility that you have all the bands stacked in a single TIFF file. So in that case, it will be called as a multi-band raster. So each file will have like, yeah, okay, just a minute. This is a different explanation and multi-band raster is different. Okay. So multi-band raster is different, where in a single file you have all the bands stacked on that, and but we are downloading Landsat data. There we downloaded different files, and we'll try to we have saved everything in a folder, which I have just shown you in this folder. And let's suppose you have some kind of a raster data within a folder, and you want to perform similar kind of analysis within all these the files. So how can you do that and then save that output after processing it into a different folder by creating it? No. Yeah. In this different folder, again, I have created a different TIFF files after doing my processing and saved it here. So that's how, like, how this whole process will go. We'll just look into it one by one. So one of the problem statement that I took for this example, that is, let's suppose you are starting with Landsat multiband imageries stored as an individual files, not as one file with all the bands together. We have individual files for all the bands. Using Rasterio, we'll try to see how you can read the file. And after reading the file, you are only reading the required pixel. So yesterday we learned about window reading, like how can you like extract a certain area of pixels and perform analysis on that. So since today we'll be applying that same logic, that how can you like you will be using Rasterio to read a required pixel window, and then apply a single AOI mask. Single AOI mask means the same example that we did yesterday for a single file, that we have a vector AOI file, means area of interest, a polygon geometry. Using that geometry, you want to mask across all the files, and then after you are doing that masking, so yesterday when we were writing, we only saved a single file as an output, but today we are doing the masking in 6 to 7 files at a time. So we will be writing 6 to 7 files at a time in a output folder. Once you are doing this process, so there will be three things. First one will be reading the folder. Second one will be the uh, reading all the files. Then once you are reading the files, all the bands that are there inside that folder, you will read that. After reading those files, you will convert it into an array, and then in that only a specified piece of pixel using Windows you will fetch, like with the help of AOI we will fetch read only those arrays. And once that is done, we will mask it using the AOI geometry that we have. Once we are done with the masking, then we will compute the per band statistics. So what do you mean by the statistics? Let's suppose you have a DEM file, means digital elevation model, and you want to clip it with some kind of a geometry. So you clipped it, and then after that you also want to do a quick statistical analysis on a set of DEM file that you have, that okay, in all these files, what is the minima, maxima, and mean values are present for the digital elevation model. That is another example. In the same way, in this, the raster I have downloaded is for Landsat. So you can simply, maybe you are having rasters for different timelines, DEM or any raster you have, for where you want to like calculate any kind of a band statistics. So then we'll compute the band statistics, and then what will be the output? The output will be the all the files which you have extracted after masking. Then you will generate a final single CSV report. In that CSV report, we will see that how all the band statistics are calculated for every single file, and we will be saving that file in a output folder. This is the similar thing that I just said, that apply one AOI as one polygon, and then on all Landsat bands. So in every single file, we will apply only one AOI geometry with loading full raster into memory. Without loading full raster into memory, same as I mentioned, like the window reading, we will do window reading. Then we'll compute per band statistics, and then we'll save the clipped raster and the CSV summary. So if I want to do all these things, so there are few things that you need to check first, that how many bands are present within your data. Are they single band? But by default, we already know that Landsat have only one band per file. So that's done. Then you need to make sure that your AOI geometry CRS and your Landsat CRS are same. If they are not same, then you need to match it. Otherwise, you will not be able to do the masking. So we need to do the like check the CRS and maintain the same CRS in both the files. Once that is done, we need to handle the no data. When we need to handle the no data, we need to handle the no data when we are doing the per band statistical analysis. At that time, we need to handle the no data. Otherwise, while calculating, let's suppose a minima, a maxima, a mean, if you will not remove your no data values from your whole data, it will create news, and it will create noise and give you false results. Uh, with this also we learned yesterday, like if you're opening the file first, that means what you are trying to do, and why actually you're preferring Rasterio instead of any other library. Rasterio is preferred because Rasterio helps you to load the raster data, and it just open the file handler. So actually raster is memory efficient, so that's why raster is more preferred rather than just normally opening the file and then converting it into a NumPy array. So what all libraries we will need for this? We will need OS library, Rasterio. We discussed OS is which something new for you. OS is basically we will be using it to create a folder. So what OS will do, it will help you to make the folder within your directories with the help of the Python. You don't need to necessarily create a folder by yourself in your location or in your directory. So let's suppose I will just delete this output folder for now. Okay, so I only have Landsat Delhi folder and I have a AOI file with me. So OS will help me to create the folder, and then Rastereo we already discussed. Mask for masking, GeoPandas for, like, obviously we'll be reading the polygon file as a with the help of GeoPandas. NumPy for masking, for calculation, for arrays and everything, and pandas we'll see what we'll use. So till now when I used to give the demos, so I used to like make small thing and it was all scattered everywhere. So till the point, like, if I want to use this, I used to load this and then one by one I used to do everything. But today I have consolidated everything so that you can also understand whenever you are writing a Python code full-fledged, you should make sure that whatever file you have, first of all you create the variables for all your paths at one place, so that, let's suppose you are going through your scripts or anything, it's easier for you to look for it and maintain it. So these are few standard practices which I'll keep on telling you in between, and you need to make sure that whenever you are writing the code, you follow a few these practices, because coding a lot of people can do, but like organized coding is the key thing, so that if you're passing on your script to anybody else, they'll be able to understand what you have written. So that's the two thing which you need to take care of. So first of all, we have made all the variables where we have stored whatever path we need in our whole analysis. So in the whole analysis, first of all, I need to fetch my folder where I have stored my raster. So I have created a variable for my Landsat folder. Then I need a path for my AY geometry. Then I also need a path where I'll save my output. And then, so I've created a output folder and then clip folder. And you will see that this path is still not present within my directory, but I have just defined it here right now that this will be my path. Same for the CSV output. Till in my drive, the folder is still 2502 only. So till 2502 is your path from your directory. And this is the path that what folder name you want to give, you just write it. And then what file name you want to give, you just write it here using the extension. Extension and everything you need to give if you are writing the file into CSV or anything. For rasters, when we will write later, we are handling at that period time that in which format we want to save the raster. Clipped is just a folder name. That's why here there is no extension along with the file name. This is still folder, clipped folder. Now, what this line is doing, this line is basically creating a folder here, because this we need to create a folder here, that if this particular folder is not present within my directory, so if it exists, okay, true means if it exists, just ignore it. And if it doesn't exist, create this folder. So I'll run this and then you can see that now we have the folder here, output, and inside that we have a folder here, clipped. So our folder is ready. So that's how you can create the folders within the Python. In if you're working with Jupyter or in your local system, then it will create in your local directory. Since we are working with Colab, so it is creating the folder in your Google Drive directory. Here I'm just trying to check that what is the CRS for my Landsat data that I wanted to check. So with rastereo.open, I just pass the file path name. This you can do by any ways that you want to do. My only intention was to check the path, check the CRS, sorry. So this CRS is 32643 for TIFF file. Now we will check the CRS for dissolve AOI as well. So since we had the path here, so first thing first, what we did, we read the AOI here using GPD, GeoPandas library, gpd.read underscore file, and we passed the path here. So in AOI GDF, what is there? It will create an array using the GeoPandas. GeoPandas basically data frame. It has fetched all the data from there in this. And then after that, in this, we are just dissolving the geometry. Why we are dissolving the geometry? Yesterday we have seen in this AOI file, we have 5 to 6 zone inside this. So when there are 5 to 6 zone, I only need a boundary geometry for doing the masking part. So that's why I'm dissolving this. So now I'll get only the outer boundary for my Delhi geometry, so that which I'll be using for doing the masking. Okay, just if it is dissolved, and we'll check the CRS. So right now the CRS for AOI dissolved is 4326, whereas the CRS for my raster datasets are 32643. And I have checked only in one of the rasters, because since all the files are coming from a single data source, so obviously all the other files will be in 32643. So what we'll do, we'll convert this AOI into the 32643 coordinate system. So for converting, we'll use dot to CRS. So AOI dissolved is equals to AOI dissolved, the file name dot to CRS we have passed, in which coordinate system you want to convert, you will just pass this here. We have passed this. And now this is something extra that we are doing. We are basically converting our AOI, whatever whatever JSON, whatever geodata frame that we created here, we are converting it to have like a fetch the geometry column out of that. Because why we need the geometry column? We are just fetching it so that we can directly use it for doing the masking. Either you write fetch the geometry column here like this, or like the way yesterday we did like here when we were writing AOI geom dot geometry. There are two ways to fetch it. So yesterday we have seen that how to do it like the other way. So for today I just wrote it like this. If you want to just fetch the geometry straight away, so that you can use it directly when you are doing the masking. So this will basically create a list of geometry which are present within your data. So that's why it is fetching the geometry column. In a geodata frame, we discussed that we have a separate geometry column. So that is what we are trying to fetch here. Like from AOI dissolved dot geometry, ilog 0 means like the zeroth index from the geometry. Like everything which is coming in that geometry column, since it is only a single geometry, that's why we did ilog 0. So it will fetch that particular geometry safely. So this is done. Now come the main part. Here we are doing three things together. Firstly, in the first line, we are looping over the Landsat folder for band file in sorted. We are just sorting it out and then open it. OS library list directory is basically it helps you to open the path and everything. So you will use os.list directory and then you will pass the name of your folder where you kept all your raster dataset, so that you can loop over every single file for creating a batch output at a time. So we are using for loop here and we have passed our folder path in. So first line will do loop over every single file within this folder. Once it is looping over every single file in this folder, what this line will do? Anybody wants to try what we are trying to do here? It's similar to what we like learn in most of the sessions. Nothing At least tell me what this means. Anything like theoretical only is tell me, if not the correct answer. Nobody wants to try? Yes, no, maybe.
Mm. Ma'am, is it like the band file, the name is in the lowercase, we are doing it in the lowercase and checking if it ends with dot diff,
Yes,
then
correct.
we continue.
Yes. So what we are trying to basically check here that only take the file which are TIFF files. Otherwise, if they do not have the extension of .tiff file, so just skip those files. Right now in my folder, I only have the expected files only, but there might be a case that whenever you are working in a very messy folder or where you have a lot of things you kept at one single place, and obviously the folder which you directly download from Landsat that contains some metadata information, some txt files as well. So to avoid reading those files, we usually keep these kinds of checks that only read TIFF files because for this particular process only TIFF files are required. So we are just preventing any kind of a error which may come across when this loop is running. So I told you about the error handling and catch exceptions and everything. So the reason is simpler that whenever you are writing any loops or any kind of a function or you're running that function, calling that function, so along with writing the code, it's always advisable to write for the worst scenarios as well, so that even if something crashes, your whole code is running smoothly. So for that reason only, we kept this line, no other purpose. Next, in this line, basically, it is creating a full path to the band. Till the band file, we are now creating a full path because in Landsat folder, we are only reaching till the folder path. And then in band file, you are fetching the file. So it is basically creating a slash and then a path till your file. So once you have created a path and joined it together, so os.path.join is basically joining both the files, means the path till Landsat folder and then the slash file name. That is what it is trying to do. And once you have the whole path, simply you will pass it inside with Rasterio open. And similarly, like we did yesterday, like we will open that particular file. And now for masking, the code was simple. We used to pass the clipped image and then clipped transform. So and as SRC is basically this is kind of a raster dataset object that we're trying to create after we are reading the file. So what all this thing will go, SRC will come along with whenever we are opening the file. It comes with CRS information. It comes with pixel information, means what is the value of that particular pixel, what is the coordinate, what is the transformation, and what are their no data values or whatever the no data value is present in that. It will come with everything. Till now we haven't removed no data or anything now because for masking it was really not necessary. So it's intact, it's there. We are just reading the file, and after reading the file we created a path, passed into a raster.open and opened it as a raster dataset object. We have all the information. Now we will use clip it using the AOI geometry. So when you need to clip it, we will use the function rasterio.mask.mask. But since we already imported mask from the internal, rasterio.mask.mask was the function, but we imported mask from rasterio.mask. That's why we are only using mask here, not the whole thing. So in this The function is basically mask, which is coming from rasterio.mask.mask, not directly mask. You need to remember this. Maybe interviewer a lot of time asks this particular question to just confuse people. Then after that, we will pass the few of the parameters which are needed for like clipping the geometry. So SRC is the first, like it will give you your raster data. What do you target raster? This will give you by using what geometry you want to clip it. So it will give you that. Then crop is equals to true. Why we are doing crop is equals to true? Basically, output extent is only like AOI bounding box. So that is why it will basically first just crop your whole raster to the bounding box of your AOI, and then it will try to do the masking. So that is what happened in the behind. And what masking will do, all the pixel values which are outside the geometry. So there is a difference between the bounding box and there is a difference between the bounding box and the geometry of any kind of a polygon layer or a polygon you have. Bounding box is the rectangular box that is created like a outer boundary of whatever irregular shape geometry you have, whereas the exact geometry is the exact location of your polygon line which is running through it. So crop is equals to true will crop out the raster data with the bounding box of the AOI geom. Whereas masking, what it will do, it will work upon the inside geometry, like the irregular shape of the polygon that you have. And then it will make all the pixel value which are outside the geometry but are part of your bound cropped part, it will make it as a no data value, or it will make that value as zero, like null, negligible. So that's why it will come as a plane, whereas the center part which is coming inside your polygon geometry, you will extract that part only. The values from that part only you will extract. Now, what are we trying to pass here? That we are trying to pass the parameter here, like no data is equals to src dot no data, so that outside AOI is set to no data. So outside AOI part, what I just mentioned, that part should completely set to no data only. Then only your inside, like the main geometrical part which you are trying to mask out will come like in a proper way. Then yesterday we learned about profile. Profile we used basically to bring out few information regarding the metadata of your raster files. We created a copy of the profile from the raw raster file, and then we used that copied profile when we were writing the by writing, I mean when we were saving the output in a different file. So that was the reason we created a profile. So today I used a term called meta. So meta and profile go hand in hand and they are similar to each other. Dot meta will also give you the profile information, whereas dot profile will also give you the both the information. So yesterday we have seen how to fetch the profile. Today I am using dot meta. So both the things are covered. So now I am creating a copy out of this and saving it into a clipped meta, because now I am creating a metadata for my clipped raster. So just I created a variable and I have saved it. Now once I fetched it from my raw data, then I am putting it as update, that whenever I'll pass my clipped metadata, just update it to this information. So what is this information? This new information that you want, because once you are doing the masking, that time there will be few things which will take place. One is that your geometry will completely change. When your geometry will completely change, at that time your transform matrix will also change. Why your matrix will change? Because now the starting pixel value will change. The starting lat long x y transform rotation, everything will get changed. So if everything will get changed, you also need the new transform to be saved in your output raster. So that was the reason that when we were doing the masking, we extracted two information when we were doing the masking: clipped image, which will have pixel values and everything, and then clipped transform, which will bring out all your matrices information, lat long values, and all those things it will bring along with that. Along with that. So then when we are updating the metadata, we just pass the newly formed transform which we fetched from here, and then the new width and the new height, because obviously now the total number of pixels, rows and columns will get changed. So that's why we just pass here. And with what we have updated, we updated it using shape 1 and shape 2. Because if you want to extract, if you, for any of the raster or any of the band, if you want to extract the shape, what it will give you rows and column. So similarly, you just shape 1 means it will fetch the rows, and shape 2 will give you the column. So simple, height and width. So we have extracted important information, updated it. Once we have updated, we have the metadata information now. So once you have the metadata information, now what we are doing, band data is equals to clipped image 0. Now what we are trying to do, we are now removing no data information. Why we are removing no data information? Because now we reached to the third stage of our activity, which is computing the statistics. So till now, first thing, we looped over every single raster. When after we are done looping, then we made sure that only TIFF files are read. Once that is done, we are joining the path from folder to exact file. Once you have the path, then we are opening the raster file. We are opening the raster file. And one more thing, you need to make sure of the indentation as well. Why? Because everything will should go in line and should go inside the for loop. Because whatever process we are doing that process at one time for one single band, then it will run the loop again, then every process will go again, every process will go again. Even if you do a little bit here and there, it will give you wrong results. So make sure that you are writing it properly. Okay. So once we opened the file, then we applied AOI mask. Once that is done, we have created a metadata and then updated. Once that is done, our cropped image is ready. Like not image, cropped raster, masked raster is ready for us. Once we have the masked raster with us, which is basically coming in what? Which is coming from this clipped image 0, then clipped image 1, clipped image 2. That's how it will come. So then we are just storing it here in band data. So once that image is here, and after that, now we are actually processing with the no data. Here, what we are trying to do, we are kind of like removing all kind of a no data pixel. So for that also we used a conditional logic. What conditional logic we used? Anybody wants to explain? At least try once. If condition we are using, what this particular line we are trying to do here. So basically, we are checking that if within SRC there is no data present, if SRC dot no data is not none, means uh, if it's not none, means if there are no data values present within my data, then fetch, go into the band data, fetch the band data, and band data should not be equals to SRC dot no data, and then fetch that particular value. And after that, here we are just converting it into a NAN. So band data not np.isan band data. What this line will do, this will basically convert all band data into NaN value. Yesterday we converted it directly like using is equals to NaN, but today we have used this way. the another way to like convert the data into NaN value instead of random invalid data values. So once we have cleaned like a array for our files, then we are computing the stats. How we are computing the stats? Simple. Stats should have a band file name. So what band file will give? Band file will give you the name of the file. And then uh, if you want to calculate the minima, so np dot minima, you are passing the band data, and then float, because minima will have the decimal values, so that's why float. Similarly for max, similarly for mean, min max mean np dot std, and then if you want to calculate the pixel size, so that how many total number of pixels are now present in my raster after this. So for that, we are just calculating the size of my band data. So it will be an integer because it will be a count, it will be a number. So it will give you integer band data dot size. So in this stats dictionary, we have created a like a dictionary object where we are saving all the keys, and with that keys we will be fetching the values. So once you have that, now we are appending the list. How we are appending the list? We have created an empty list before, stats underscore list. We already created a empty list. Now in that empty list, we are just updating the stats information. So stats underscore list dot append. So in this list, if you have to add new information, we use dot append, and we just passed on this stats along with that. So it will create a list from that. Now, once you have a list, since you cannot save list into a CSV, if you want to save something into a CSV, you need a data frame, because CSV is kind of a data frame where you will have columns, and in that column you will have values. So since we now need to create the data frame from the list, for that matter, we needed pandas library. So that was the reason that we imported pandas here as PD. So since we have the list, we will convert the list into a pandas data frame, which is pd.dataframe stats underscore list. We have the data frame df here, and now we'll just save it to CSV as an output. We have already learned in the classes in the session where we understood how to do the file handling and everything. There we understood how to write a output or a data frame which you have created, or a list that you have created, into a CSV file. So if anybody have any confusion, you can just look back into that session where we learned about file handling. So this is the same thing. We are trying to save the output or save the data frame that we created using the list. This was the list. This is the data frame that we created. Now we are saving it into an output. This is the kind of a CSV output file name that you gave to CSV. This is the file name. Index should be false. That's fine. And then I just wrote print processing completed for CSV, so that till the time my code reach here, it should print this line, so that I know that this process is done for that particular file. Once statistics are calculated and everything is done, now what we'll do? Well, now I have to write the particular array or a mass raster that we have, that we created, into a proper TIFF file as an output. So simple. For that, I will use with rasterio.open. Again, I'll again open that path, out raster. Just a minute, guys. Okay, so simply we'll open that output path, and we'll open that path in the write mode, because I need to write and dump the information in that particular raster. Then I will attach whatever profile information that we have, as this is just a object, dataset object that we are creating, and desk.write, and will simply pass clipped image here. What was the clipped image that we created? We were fetching from here, clipped image. We will simply pass the clipped image. Clipped transformed, we already passed it through the clipped meta dot update. So both the information are now like we just updated here, and then print this. I'm printing the band file here, and then I'll just run this. So you can see that one by one it is now doing the batch processing for every single file, and it is printing, and the output is created. So if you want to see the output, you can see that I have clipped rasters here, and then I have a CSV file here, which will contain the name of the file. Okay. So this will contain the name of the file because we pass the name of the file as well while we were creating the list for our uh, statistical output here. I pass the band file. So band file, then the minima value, maxima value, mean value, standard deviation, pixel count, everything is there. So this is one such example how you can do the batch processing and do the analysis, calculate the analytics, create the report and everything. In a similar way, I will ask you to do like a little more hands-on on this. Like try to come up with your own set of examples, whatever you want to do, like whatever you can think of that, okay, fine, this is the possibility that I can have using Python. What else I can do using this? So right now, let's suppose I did masking. You can try doing join and everything and then create a statistical report out of that. Let's suppose you have three, four files saved in a folder and you are doing the spatial joins between those layers on the basis of some kind of field and then coming up with the output. So try something like that. And yes, this was it for today's class, and I'll just finish it here only so that you get time to understand raster and hands-on exercise a little bit, and then we'll continue with another tomorrow. Okay. Any questions till now? Or like you'll practice and then maybe you'll ask me.
I think first we should practice this, ma'am, because it's a
Yeah, I
little
know.
lengthy.
Yeah, okay. Cool. Okay then. Take care. Good night. Bye bye. I have already shared everything, data and everything. So like you can start practicing now. I think you must have received.
Okay, ma'am.
Okay. Bye bye.